Welcome to Educator.com. Today we're going to be discussing a special application of the Pythagorean theorem, and that is the distance formula. The distance between 2 points, x1, y1, and x2, y2 in the coordinate plane is given by the following formula. Now, let's go ahead and look at the similarity here between this formula and the Pythagorean theorem, and how this is related. Consider 2 points. Let's say you're given the points 2, 1 and 5, 6. So this could, either one of these could be considered. I could call this x1, y1, and x2, y2, or I could do it the other way around. It doesn't matter as long as you're consistent. So if I say this is x1, y1, then I'm going to be putting x2 first, y2 first. This one second, this one second, as long as I don't mix and match. So anyways, I have 2 points. I'm going to go ahead and graph those. And my first point is x is 2, y is 1. So this is point 2, 1. My second point is 5, 6. So that's going to be right up here. A little bit over. X is 5, y is 6. And if I want to know the distance between these two, I can use this formula, and the graph shows you how the formula is related to the Pythagorean theorem. So this distance. What I can do is I can say, based on these 2 points, I could draw a triangle, and I could do that by dropping down vertically from this point and going across horizontally from my other point. So what I'm going to end up with is a third point, and this third point is going to be at x is 5, y is 1. Okay, so I started out with 2 points. I want to know the distance between them, and I developed a third point based on the location of these 2 points to form a right triangle. Well, I know by the Pythagorean theorem that these 2 sides, call them A and B, are related by the Pythagorean theorem. And if the hypotenuse here is D for the distance, A squared plus B squared is going to equal D squared. Now, the question is, how do you find the sides, the length of the sides for A and B? Well, you can see that you could find the length of side A simply by subtracting this value of x right here from this value of x. So if I take x2 minus x1, which is going to actually equal 5 minus 2, I'm going to have the length of A. So looking over here, I said that D squared equals A squared plus B squared. Therefore, D squared is going to equal A squared, which is x2 minus x1 squared, plus this side, side B. So for side B, to find that length, all you need to do is subtract these 2 points. So here I have I had x2, and this is y2, and this could be x1, y1. So I can simply find that by subtracting these 2 points. So I'm going to end up with that same result, where I'm going to get 1 minus 6 squared. Now, I actually don't want, or x2 or y2 minus y1. y2 minus y1, y2 minus y1 is y2 minus y1. Okay. So if I go ahead and I just want D, I'll take the square root and I'll get the square root of x2 minus x1 squared plus y2 minus y1. And you could go ahead and figure that out. And if you were to figure that out, you would plug in these numbers, go ahead and find the result, take the square root, and that would give you the length of the side. So the distance formula is based on the Pythagorean theorem and the fact that the distance between these points can be graphed out and a right triangle can be formed, and then you can apply the Pythagorean theorem to find the length of these sides by knowing the x and y coordinates. When you know these two sides, using the Pythagorean theorem, you're going to know the distance. So how do we apply the distance formula? I explained where it came from, but how do we apply it? Well, if the distance between 2 points is x1, y1, and x2, y2, then if you are given 3 of the coordinates, x1, x2, y1, y2, 3 out of the 4 are given, then you can find the 4th coordinate by using the distance formula. Okay. For example, if I'm given a set of points, x1, y1, given that y1 is 1, x2 is 8, and y2 is 5, and I'm told that the distance between the points equals 5, then I can use the distance formula in order to solve this. So let's go ahead and apply that. The distance formula equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So distance equals the square root of, I'm going to let this be x1, y1, x2, y2. So that's going to give me x2 is 8 minus x squared plus y2 is 5 minus 1 squared. So the distance equals square root of 8 minus x squared plus 4 squared, or distance equals the square root of 8 minus x squared plus 16. I'm going to go ahead and square both sides and recall that distance is 5. So I'm going to substitute that in. 5 equals the square root of 8 minus x squared plus 16. 5 squared equals 8 minus x squared plus 16. Okay, that gives me 25 equals 8 minus x squared and plus 16. Go ahead and continue on up here. Subtract 16 from both sides. That's going to give you 9. 8 minus x squared. Take the square root of both sides. Is 3. Keeping that square out of here. Taking the square root of both sides. That's going to give you negative 5 equals negative x. And I'm going to multiply all that by negative, the whole thing by negative 1 to just make this x equals 5. But let's stop and look at this for a second. Remember that when you take the square root like this, what you actually have to say is that this is plus or minus the square root of 9. So actually, what I have is this is plus or minus the square root of 3, which then ends up being plus or minus 3 equals 8 minus x. So I worked this out for positive 3, but let's go ahead and work it out for negative 3. Negative 3 equals 8 minus x. So actually, I'm going to get a second solution where x equals 11. I initially just worked it out with the square root of 9, 3. That was it. I figured it out. I got x equals 5. But actually, if I make this plus or minus, I'm going to find that I have a second solution where x equals 11. So x equals 5, x equals 11. Now, think about how this can be possible. Let's map out these coordinates. 2, 4, 6, 8, 10. So coordinate 8, 5, right here. My second coordinate is at y equals 1, and it's saying that x can either equal 5, so if x equals 5 and y equals 1, I'm going to have a point right here, x equals 5, y equals 1, and then I'm going to have a second point over here at x equals 11, y equals 1. And the reason this is possible is these 2 points are the same distance from this first point. And that's how we actually end up with 2 solutions in this case, where x equals 5 and x equals 11. So it's very important to remember to take both the positive and negative square root so that you end up with 8 minus x equals plus or minus 3, and then you solve for 8 minus x equals 3 and 8 minus x equals negative 3 to yield 2 solutions. Both of these solutions would have the same distance d from that point. Both of these x values. In our first example, we're going to do a simple application of the distance formula. So recall that the formula is the distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, just substituting in, I'm going to let my first set of points be x1, y1, and my second set of points be x2, y2, but you could certainly assign it the other way around, as long as you don't mix and call this, x1, y2, or mix them up like that. But I could have just as easily done it the other way around, subtracted my x1s from my x2s. Okay. D equals x2, which is negative 12, minus x1, which is negative 3, plus y2, which is negative 5, minus y1, which is negative 7 squared. So I have a negative 12 minus negative 3. That's going to give me negative 12 plus 3 squared plus negative 5 minus negative 7. So it's going to be negative 5 plus 7 squared. So D equals the square root of negative 12 plus 3, which is negative 9 squared. So negative 5 minus negative 7, that gave me plus 7. So negative 5 plus 7 is going to give me positive 2 squared. So the distance equals the square root of negative 9 squared. So that gives me 81. And then 2 squared is 4. So the distance equals the square root of 85. So simple application of the distance formula to find the distance when given 2 sets of points. In this next example, we are given the distance and we're asked to find the x-coordinate for one of the points. So find x if the distance between the points, x negative 9 and negative 3, negative 2 is 8. All right, so distance formula. And I'm given the distance. And I'm given some points, but I'm missing a point, and they need to find the value of that point. So I'm going to let this be x2, So I can have that variable right here. And this is going to be y2. This is going to be x1. This is going to be y1. So this is going to be x2 minus -3 squared plus y2, which is -9, minus y1, which is -2. All of that squared. So 8 equals the square root of x minus -3 squared. Simplifies to x plus 3 squared, plus -9 minus -2 simplifies to plus 2. Continue to simplify this. This gives me x plus 3 squared plus -9 plus 2 is -7 squared. So 8 equals x plus 3 squared plus 49, the square root of all that. Now, in order to solve this, I'm going to go ahead and square both sides to get 8 squared times equals, 8 squared equals x plus 3 squared plus 9, this entire thing squared. This is going to give me 64, and radical times a radical, I'm going to eliminate that radical sign and get x plus 3 squared plus 49. Simplifying this by subtracting 49 from both sides to get 15. Coming up here to continue the problem, this is going to give me, if I take the square root of both sides, so let's just continue this up here, 15 equals x plus 3 squared. There's various ways to solve this. One way is just to take the square root of both sides, and that's probably the quickest way here. So let's take the square root of both sides. Let's get the square root of 15 equals x plus 3. But when I do that, I actually have to take plus or minus the square root of 15 when I'm solving a quadratic equation like this. And remember, you can end up with 2 solutions, 1 solution, or no solutions with a quadratic equation. So solving for x, subtract 3 from both sides. So x equals, I'm going to write this in the more standard form with the variable on the left, x equals -3 plus or minus the square root of 15. So those are 2 solutions for this set of points. Given this x coordinate, the distance between these 2 points would be 8. So again, distance formula. This time I'm given the distance and I'm given 3 of the 4 points. So I plug all those in, just using the variable x to represent the unknown point. Went ahead and simplified as far as I could, ended up with this quadratic equation, took the square root of both sides, and then I'm going to have plus or minus the square root of 15 equals x plus 3 to give me these 2 solutions. Okay, in this example, we're asked to find the distance between 2 points, and it involves radicals. So it definitely looks messy, but you just apply the distance formula as usual and follow the rules for dealing with radicals. All right, so I'm going to let this be x1, y1, and x2, y2. So starting out with x2, that's 8 radical 3 minus -2 radical 3, and this entire expression is squared. Now, y2, that is -4 radical 5 minus y1, which is 3 radical 5. This entire expression is squared. Taking care of some of these negative signs makes things simpler. So negative times a negative here gives me a positive. So this is plus 2 radical 3, expression squared. Here, I still have a negative sign. I just have a negative, so that remains negative. Okay, now, in this next step, I'm going to go ahead and look at what I have in terms of addition and subtraction. And I realize that I have like radicals. Because I have like radicals, I can actually add and subtract them using the distributive property, as we've discussed in earlier lessons. So this is going to give me 8 plus 2, radical 3, and this entire thing is going to be squared, plus negative 4 minus 3 times radical 5, and this entire thing is going to be squared. Simplify this. 8 plus 2 is 10, so 10 radical 3 squared plus negative 4 minus 7, that gives me a negative 7 radical 5 squared. Now all I have to do is simplify this, take the square root, and then I'm going to have my answer. So 10 squared is 100. Square root of 3 squared is 3. Negative 7 squared is 49. Square root of 5 times the square root of 5 is 5. So now it's getting much cleaner looking than we started out with. 100 times 3 is 300, plus 49 times 5 is actually 245. Add these two terms to get the square root of 545. So even though this started out very messy, if you notice, the x terms are like radicals and the y terms are like radicals. And that allowed us, when we applied this formula, to subtract those two because they were like terms. And so that's really all that was done here, is to substitute these in, take care of the like radicals, add or subtract them, and then squared them. That got rid of the radicals, and then found the square root. So given these two sets of points, the distance between them is the square root of 545. Okay, in this problem, we're asked to find y if the distance between these 2 points and these 2 points is 4. So we have a missing coordinate. Using the distance formula, and I'm given the distance 4. x2, I'm going to have this be my x2, y2, and my x1, y1, just to keep everything straight. So this is 5 radical 2 minus x1, which is 3 radical 2. This entire expression is squared. y2 is unknown, so I'm just going to call that y, minus y1. All of it is squared. Okay, so I now have 4 equals, and I want to do any simplifying that I can, and what I see under here is I have like radicals. So both of these have a radical 2, and that means I can subtract. So 5 minus 3 is 2, radical 2 squared, plus y minus 4 square root of 6. So 4 equals, let's go ahead and simplify this. 2 squared is 4. Square root of 2 times the square root of 2 is 2. This is still squared. Okay. So now I'm left with 8 plus y minus 4 radical 6 squared. What I want to do now is get rid of the square root, and the way I can do that is by squaring both sides. So square both sides. And this is going to give me 16 on the left side, which allows me to do some more simplifying. Continuing on at the top of this column, 16 equals 8 plus y minus 4 radical 6 squared. Subtract 8 from both sides to simplify. Now, there are multiple ways to solve this, but the simplest way is actually going to be to take the square root of both sides. So I'm going to go ahead and take the square root of both sides, solve this quadratic equation. And that's going to give me the square root of 8 equals, and since this is squared, if I take the square root of something squared, it's going to give me this plus or minus the square root of 8 equals y minus 4 radical 6. Okay, I'm almost to the end. I just need to isolate the y by adding 4 radical 6 to both sides. Plus or minus the square root of 8 equals y. I'm just going to rewrite that with the variable on the left as it's usually written. This was another messy one. Fortunately, we did have radicals that were like radicals, so that when we applied these x terms into the distance formula, we were able to subtract these two terms to get 2 radical 2 squared. So that simplified things a bit. Continued simplifying down to here, squared both sides of this to eliminate the radical. That gave me 4 squared equals this whole expression, which was 16 equals all of this. Subtracted 8 from both sides, and at that point I was left with this, and I needed to solve for y. And the easiest way to do that was to take the square root of both sides, which gave me, got rid of that square, and gave me plus or minus the square root of 8 equals y minus 4 radical 6. Solve for y, and these are my 2 solutions. Okay, that concludes this lesson about the distance formula on educator.com.